Oh no. Sorry. Yeah, don't simplify if you have a quotient rule, at least for now. We'll want to simplify it at some point, but I don't know. It makes it easier for me. I generally don't look at the simplified version anyway. You can do it if you want. Looks like some people are finishing up. Don't hurry, but some of these should be pretty quick, and then of course some of them a little bit longer. We're doing I'm not rushing you, am I? All right, here. That's such good work. I keep seeing right answers. I love it. Do I have them all? I think so. So where did my staple go? That's not mine. This one's mine. There. Yeah, this one doesn't work as well as this one. Anyway, okay. Um, so let's go ahead and go through this just to make sure that we're all on the same page. I think most of you. There were a couple of minor issues, especially with letter B, but we'll talk about that. This was super easy. Isn't that fun? It's so easy. Once you start, you've gotten this internalized. I just want to point out that 2 weeks ago you would have had no idea what to do with this. Well, most of you. Some of you might have. But now it's like second nature. You look at it and you're like, oh, easy. So very nice. This one, not so much, but mainly because of the fact that you may still be struggling with a little bit of the algebraic expression here. This is x to the 6/5. And so when you do the derivative, it will be 6/5 x to the 6/5 minus 1, which is 1/5. Most of you had that. There are a few people who had a little bit of a different notation, perhaps, at least as I was glancing. Cosine x minus 3 sine of x. This should be second nature. You should be able to just rattle that off super quick, just like you did this one. So eventually the trig functions will become as simple as the polynomial. Anyway, over here, okay, product rule. I know, throwing two things at you at once, but we can do this. This will be 3x squared times tangent. That's the derivative of x cubed times the tangent, plus x cubed times the derivative of tangent, and the derivative of tangent is secant squared. So that wasn't too bad. Product rule, whatever. This one is just the secant times the tangent. And if you forgot that, you could always do this using the quotient rule and 1 over cosine. So that's another option. If you ever forget this, like on an exam, you can always rederive it. You can do the quotient. I know it's kind of a pain, but you could. It's an option. So after today, there's an even easier option actually after today's lesson to doing that. But we'll get to that in a bit. Then this one, quotient rule. Speaking of the quotient rule, let's see. It's low D high times cosine of x minus high d low over low low. There. As I mentioned to Thomas, eventually we're going to want to simplify this for a variety of reasons, but for now, I'm just thrilled that you got the form correct. So I saw a lot of correct answers. Hopefully you're getting this straight, that it's low d high minus high d low. If you've got these two switched, then you've got it wrong, but at least you've got the general form, but do get it, try to get them correct so that it's the bottom times derivative of the top minus the top times derivative of the bottom. Okay, so today we're doing the chain rule. There we go, which is going to give us another tool to finding derivatives. My mouse is still not working? Yeah, my mouse is still not working. I think I need new batteries in my mouse. This one. Sad. I hate the trackpad. So I'll try to remember to get a new battery for it. So chain rule. So why do we care? Why do we have another rule? I know, because we're mathematicians. So the reasons for the chain rule are these. These are the reasons for the chain rules, because most functions aren't as clean as we'd like them to be. For example, sine of 3x. Sine of 3x, the moment you have the 3 in the parentheses, it's no longer the sine of x. You have sine of 3x. To do the derivative, we're going to do something similar. You already know the derivative of sine of x. We're going to use that to find the derivative of sine of 3x, but there's an additional layer here because of that 3x. So that's one reason, is because of functions like that. And if you're familiar with trigonometry, you know that you get a lot of sines of 2x, sine of 3x, just in the course of doing math with sines and cosines. This one, where you have the cosine of x plus 2 quantity squared. That one, at least, you could probably do something with this, but it's going to be I guess you could use the product rule with that, couldn't you? But this one you couldn't. This is the square root of x squared plus 3x, or minus 3x. So anytime you have functions embedded in other functions, we're going to use what's called the chain rule, because we don't want to use limits. If we can avoid it, we don't want to use limits. Now, because I'm a mathematician, I have to do the limit once. I've told you about this, didn't I? That I feel the need to do the limit. This is what I want to compute, is the derivative of a composition of two functions. Each one of these things back here, by the way, is a composition of two functions. Let me just highlight really quick. You can see here that this is the sine of 3x. So you have the composition of sine with 3x. I won't highlight the others, but you have the same idea. This is the composition of cosine of x. Oh, actually, the square is the outer function. The inner function of cosine x plus 2. This last one, it's the square root of x squared plus 3 minus 3x. So you have this composition, one function evaluated at another function. So that's what I want to find the derivative for. And if I can come up with a rule, we're going to call it the chain rule. If I can find a rule for this, then I'm going to be all set for all of those other functions that we had on the previous page. In fact, we'll do all three of those in just a minute. So let's just walk through this. Like I said before, you aren't going to care about most of this. In fact, it will be the next slide. So you could do this. You could write down the derivative of f of g of x equals, and then just sit back for a minute. And when we get to the very end, in fact, it'll be 2 slides from now, I'll have the actual thing. Now, the proof that I'm going to do, or at least not the proof, the derivation, is going to use the alternate version of the derivative. Instead of using the limit as h approaches 0, I have the limit as x approaches a of f of g of x minus f of g of a over x minus a. It's the same exact limit, but it's just a little different way of looking at it. But anyway, if you go through this using some tricks that So the first trick is to multiply top and bottom of this thing by g of x minus g of a. You end up with an expression that looks like this. So this is after doing a little bit of algebra. So we have this expression. This looks suspiciously like the derivative for g, and it is. This over here looks a little bit weird, but after a little bit of, I guess, algebraic hand waving, what you end up with is, so notice that I'm changing my limit over here. You end up with an expression that actually is the derivative of f evaluated at g. So you get something like this. Well, let's put it all together. Here's the actual chain rule. And I know I just went through that super quick. If you really care about it, I guess you can always go and look it up. It's not that complicated to go through that derivation. But this is the actual chain rule. And I know what you care about is, how do I deal with this on my homework? Because it's going to pop up. There's a whole bunch of problems. There were 14, but I cut it back to 9. So there's still a bunch of problems with the chain rule. So here's what we're going to do with the chain rule. Let's just take a quick example with this big, bold thing up here. Suppose I want to find the derivative of the function sine of x, let's go 3x. Let's just do that. Sine of 3x. So the way you're going to do this is you're going to have to figure out, using just what you know about composition of functions, figure out a way to express f and how to express g. Now here's the general hint, is that f will always be the outside function. So you have something on the outside, and in this case it's the sine. So over here I might write f is equal to sine. And then the g is always the thing inside the inside function. So g is 3x. Now I'm going to do this the long way until we get the hang of it, and then I'll do it there's a shortcut that we can do, but I hesitate to do that initially. But some of you will catch on quicker than others, and will be able to sort of think through this using the shortcut. But the long way is to write this all out. So f is sine, g is 3 of x, f prime is cosine. I probably should have picked someone for that. Maybe I'll get myself set up here. There we go. And then g prime is just 3. So take a minute and see what I've done there. Make sure that that makes sense. Now let's put it all together using this form. Notice that you take f prime, that's this thing, and I evaluate it at g of x. So I have to do this. I have to do the cosine of g of x times g prime of x. So let's see if I can highlight. So we have the cosine, and then I've got g of x, g of x, g of x, and then I've got g prime of x, g prime of x, g prime of x. So there it is, color-coded, but there we go. So you can see it all, but it still is confusing, isn't it? It's kind of, you've got to do a lot of bookkeeping. I know you don't think of calculus as being the same as accounting, but there's a lot of, it's necessary to keep things straight. And if you're messy in terms of your work, like some of you, no examples here, these are all pretty good. But if you have trouble, like if it's scribbling and you can't read your own handwriting, then you're going to have trouble with this. These people are all pretty good. Like, keep it as neat as possible, when you're doing this. This is from Calc 2, so these people are all pretty neat in their work. So, but I struggled with this because I I was, as messy as this looks, I was super messy when I was learning calculus. Like I'd have things written at an angle and they were script. I couldn't read my own work. So, and it caused me grief at times. So let's take a look at these three. These are the three that we had earlier. You know what? I'm going to copy this over to Notability so that we can take our time with this. See, down, down, down. So I want to find the derivative of the sine. I know I've forgotten what I was doing here. Where is it? Oh, we did sine of 3x. We've already done that one. Okay, so it's cosine of x plus 2 squared. Okay, so cosine of x plus 2 quantity squared. That's one of the things that I want to find the derivative for. So I'll just write it like this. That's what I want to do is. So hopefully you've caught on that that notation means do the derivative of what's in that big bracket there. Okay, so let's go ahead and we will do this slowly and carefully and methodically. First things first, we're going to identify f and g. Remember, f is the outside function and g is the inside function. Bryce, you know what f is, don't you? You know what g is, don't you?
G is
Yeah.
negative sign.
Oh, no. Just what's right there.
Oh, just what's right there. I'm sorry. G is just cosine plus 2, right?
That's right. Cosine of x plus 2. So no shade on Bryce. I just I just realized that it's way easier to start on the inside and say, oh, look, this is what I'm, I've got the inside. I've got something in parentheses here. Boom. That is going to be G. And then you can start from there and say, okay, what did I do? What did I do to that? And that will become your F. So the F is what you did to that thing. So Thomas, what happened to this up here? It got squared. Yeah. So your F is going to be something squared. And unfortunately, we're just going to call it x squared if we want to follow the way that well, not just your book, every book does it this way. Even though it might be nice if that was a different letter there instead of x, but we're stuck with x. So notice that the inside is this thing. The outside, what did you do to this? You squared it. So that's what I do. Now I need derivatives, but you know your derivatives. Zach, what's the derivative of f? Yeah, it's nice and easy, isn't it? And then we need the derivative of g. Allie, you know the derivative of g, don't you? Negative sine of x. It's beautiful. So this is sort of where this practicing and working and getting it into your head so that you can just do it like quickly is going to help, because things get more complicated when we throw the chain rule in. But anyway, now that we've got all that set up, now what I'm going to do is I'm going to put it all together using the chain rule. And remember that the chain rule is f prime evaluated at g of x times g prime of x. There's the chain rule. It's always going to be that way. No, it's never going to change. So let's go ahead and do this. So f prime is this thing right here. So that's going to be 2. But it's 2 times, not 2 times x. Here, you know what I'm going to do? I'm going to do it this way. There. Just to emphasize, I'll do it super slowly. So f prime is 2x, but I'm not evaluating this at x. I'm evaluating it at g of x. It's kind of like if I asked you, what is f prime of 3? You would say it's 2 times 3. F prime of 5 is 2 times 5. F prime of smiley face is 2 times smiley face. So f prime of g is 2 times g. So that's all we're doing here. Nothing fancy, just going to evaluate this. Now we'll actually plug in the g and the g prime. So that's the next step, 2 times cosine of x plus 2. And then the g prime thing is negative sine of x. Do I need to simplify? No. This will be sufficient. And I think that even on, I've noticed that Lumen is sometimes a little bit inconsistent, I should say, with their instructions. They'll say completely simplify, but then they'll accept a non-simplified answer. Or they'll say, express this as an exact answer, like some of those, like where you're supposed to have like pi over 7 or something. Well, nothing like that. Like radical 3 over 6, maybe something like that. And then they'll take a decimal. Like sometimes I feel like the instructions are somewhat inconsistent, but there it is. Now, there will come a time when we will want to simplify this, and this one isn't difficult to simplify. You can multiply through by sign and 2, distribute those, but that does it. That's beautiful. Let me get the second one here. I probably could just do it up here, just a sec. I have this here. Where is it? Let's go back to the one that we're working on, which is this one. Okay. So the next one that we're doing is this. I might as well use G, capital G. Very good. I'm going to write it like this, just to emphasize what's happening. Just so you know, it was x squared minus 3x to the 1/2 power. Just rewritten it like this. We're going to have to use the 1/2 power anyway. But now that we've got that, step 1 with the chain rule is always to identify the inside and the outside function. And as I think this is, I'm remembering this from like the years and years ago when I learned this, it's always easier to identify the inner function first. That's the thing that's inside parentheses or under something. Usually that's going to be the inside. So Ethan, what do you think the inside function in the G? What's that? Very nice. So it's x squared minus 3x. It's that thing that you're doing something to. You're doing something to that function. And then, Allison, what about the outside function? Yeah, it's the square root. So you're doing, what are you doing to that? You're doing the square root to that. And we usually just write it as the square root, in this case of x. And I can rewrite that as x to the 1/2 to make the derivative easier to deal with. Okay, as before, what we're going to have to do next is to actually rewrite, or not rewrite, just write the derivatives. And you can do these. These are not difficult. Kelsey, do you know the derivative of x to the 1/2 power?
It would be 1/2 x minus 1/2, or to the minus 1/2 power.
Very nice. So, and if you wanted to write that as 1 over 2 radical x, that's fine. I don't care. This is great. All right, onward. You don't exist, but Elena, you do. Elena, what's the derivative of g of x?
I got 2x minus 3.
That's what I got too. Beautiful. So these basic derivatives are easy. It's when we combine them that things get harder. Quotient rule is hard. The product rule, not so hard, but it's more difficult than the basics. Here, this is the chain rule. And it's hard. We got to keep things sorted out. It might be helpful to each time until you get it really stuck in your head. It might be helpful to actually write this down. F prime evaluated at g of x times g prime of x. That way you can keep things sorted out. We can maybe even, if you have highlighters, it could be fun, maybe not so fun, to actually highlight this g of x is right here. This g prime of x, oh, that was not a good choice, was it? Oh well. And then this f prime is this, that was not a great choice either, but that's okay because I can handle it. Let's put it all together. F prime is 1/2 times something to the negative 1/2 power. So that's the form of this, but I'm going to put g of x into that. So I know it's kind of confusing until you get the hang of it. Hopefully you'll start seeing how this all fits together. X squared minus 3x. And then multiply this by the g prime of x, 2x minus 3. This one I am going to simplify just a little bit, only because I find that notation to be a little bit grating. So I'm just going to write this like this. However, depending on what you would want to do with this, so this is capital G prime. Depending on what I was going to do, eventually do with this derivative, because there's various things that you might do with a derivative, and we haven't even gotten there. We're getting there, though. Don't worry. Applications are coming, and that's, I mean, we just want to make sure we understand derivatives before we get to the applications. But depending on what you're going to do with this, either of these might be better than the other. So don't feel like one is better than the other. It's just that I kind of like the look of the bottom one better than the top one. That's just me, though. So, all right, let me see what I have here. I don't want to do that yet. Hold on a sec. We'll skip that. We'll do this one. Oh, okay, good. Yeah, I've got a bunch of examples here. We're going to skip this. We're going to go right on to that. Yeah, let's try this. So I've got 3 more, 4 more. Oh, I've got even more than that. I've got a whole bunch of examples. But let's do 3, and then we'll go back. I'm skipping something. We'll go back to. So see if you can do this one completely on your own, and then we'll work it through together. We'll step through it. Don't worry. I'm not going to leave you hanging. Oh, no. Sorry. I don't know where it went. Oh, there it is. All right, this is getting a little tedious, isn't it? Well, it's not that tedious, not that bad. Let's see how you did. Hopefully you were able to get it written down pretty quickly. And maybe, well, let's see, maybe on the next one, I'll show you why this is, I guess, why I think of it as the chain rule. Probably it's why the chain rule is called the chain rule. But anyway, let's go with Caitlin. What is the inner function for this one? Yeah, so usually it's pretty obvious. I mean, it's right there staring you in the face. The outer function is a little bit harder to find sometimes, but Sienna, I know you know what the outer function is, don't you? Yeah, radical. I'm going to use t because of the t in there, but radical x, radical t, as long as you know that it's a function. And it really, honestly, you could do radical q, and it would, as long as you do the derivative, because the q or the t or the x for the f doesn't really show up at the end. Let's do our derivatives. Where are we on the list here? We are randomizing a second time. So going through again, we've been through the whole list. Allison, what about the derivative of radical t? Excellent. And I'm just going to misspell that x as a t. And like I said, really doesn't matter if you use x or t for the f function. Ethan, what about the derivative of g?
2t.
Yeah, just 2t. Now let's see if we can put it all together. I'll bet you can. Zach, what did you get when you put all this stuff together?
Do you want it like in a fraction or?
I don't. However you have it.
I got 1/2 times t squared plus 3 raised to the negative 1/2 times 2t. And then I change that to 2t over 2 radical t squared plus 3.
All right, very nice. And yeah, so that's going to be 2t over 2 times radical. And of course, you could cancel this is y prime. You could cancel the 2's if you wanted to, but very nice. Beautiful. So is everyone, we're doing okay? All right, let's see another example here. That's interesting. Okay, so let's go through the whole rigmarole again. So F, G, All right, let's see where we are. It's probably getting a little bit rote, so anyway, we'll make one more complication in just a minute. But let's see how we're doing. Bryce, what do you think? What's the inside function? That's what I would use. Very nice. So yeah, this one doesn't, usually I look for a set of parentheses or like a radical so that I can see that there's something that's going on. But here it's not quite as obvious. But once Bryce has identified that, so if you didn't identify that yet, that is correct for the inside function. Let's see if we can figure out what's going on. What is happening to that function? So Kelsey, what is happening to that function? What would you say f is? Oh, look at this. I've got an x and I've got a t. Change this to t. Yeah, very good. So 1 over whatever. And so, or you could write that as t to the negative 1, because you could rewrite this t squared plus 3t minus 1 to the negative 1 power. So there's different ways to write these things. And so sometimes it's more obvious. Like if I had written it like this, if you couldn't figure out what the f and the g are for this, hopefully it's obvious with this. But anyway, let's move on. Let's get our derivatives. We'll blow through this. Thomas, what's the derivative of f here? Okay, very good. And then we need the derivative of the next one. Caitlin, what's the derivative of t squared plus 3t? Very nice. And then we're going to put it all together over here. So who gets to do that? Sienna, do you think you can put it all together? That's amazing. Good job. So this would be something like this. If we were to write it as a single fraction, t squared 3t 1 squared. But there it is. Very nice. It's beautiful. Very good. Okay, let me see. I had one here I thought would be fun. Let's see, where am I? Is it this one? Oh yeah, that one looks like a joy, doesn't it? So let's take a look at this one. So this one, I don't even know. Well, let's do it. We can do this. Here, let's get a little f and get a little g and see what happens. So I'm going to let you make the choice as to what these are going to be, or at least I'm going to let Allie make the choice. Allie, what's the inside function for this? All right, beautiful. Okay, we'll go with that. Some of you might have done it the other way, and by the other way, if you don't know what I mean, then don't worry about it. So, but anyway, yeah, there it is. That's G. Very good. And then, if that's the case, Elena, what would the outside function be?
It will be the sin.
Sin. It is a sin, isn't it? The sine. Very good. So this thing is inside, and then sine is outside. Now we run into a problem, don't we? Because we all know what the derivative of sine is. Derivative of sine is cosine. But what is the derivative of cosine of tangent? Well, what happens is we end up having to do the chain rule a second time. So this happens more often than you'd be surprised at how often this happens, that you have to do the chain rule twice. And so what I'm going to do is I'm going to take this and do the chain rule a second time. Whoops. Just a sec. Can I just get rid of that little mess up there? Yes, I can. Okay. So with this one, so I'm changing colors. Oh, and you can hardly read it, can you? Well, too bad. No, I'm just kidding. I'll blow it up. Now it's a little bit easier to read. But still, it's kind of like if you've ever seen the movie Inception, where there's a dream within a dream. Here it's a chain rule within a chain rule. So we have to do the inside chain rule is going to be F. Oh, let's pick people. This is more fun. Oh, we're through the list again. How could that be? All right, Allison, what do you think the inside function is for this new chain rule? Yes, tangent. Excuse me. Thomas, what's the outside function for this new? Yeah, it's cosine. Yeah, so you might not have, well, no, it's important that we write it all out like this. So don't worry. Um, well, okay, and then I'll explain why this is called the chain rule here in just a sec. So this derivatives, those are easy. I won't bother you with these because you know that the derivative of cosine is negative sine. And I hope, because you got it right on the quiz, that the derivative of tangent is secant squared. Okay, so now here's the hard part, is we've gone deep into this chain rule. We have to work our way back out of the chain rule. So we're going to just focus on this one thing. It's nice that I can sort of blow this up so we are only looking at this one piece. And then after we do that piece, we'll zoom back out and we'll do the other piece. But let's not worry about that piece for just a minute. Let's do this one. So I need to get little g prime, the red g prime. So I had to go to the green, and now I'm going to do the red. So let's see. That is going to be f prime, that's negative sine of g, of the tangent, times g prime, secant squared. So check that. Just take a minute, make sure that that makes sense, because it's hard to keep track of everything. So this is part of what I mean by being careful with your accounting and making sure that you write in clear, the more like a table you can write, like keep things lined up, it'll be helpful. Okay, now we'll zoom out and we're going to take those things. Oh no, keep it. Sorry, why did that do that? There we go. Hold on a sec. Come on, buddy. There. Okay, so now we've zoomed out. All we care about are the red F and the red G. So now I'm going to take these. Oh, I should have marked this. Just a minute. So this stuff went up here. And then we're going to take the red F and the red G and put them together. So you have F prime of G of X. And so the G is the red one. This is the cosine of tangent of X times G prime, negative sine. Sorry, I've run out of room. Secant squared. That should all be on one line. My apologies. can't move things around on here as easily as I can with Notability. But here, I know this is really, I mean, beating the horse here, but let's go ahead and point out that this g of x here is this right there. And here is f prime. And then finally, one more, if you'll allow me, and that's that stuff there. Whew. Oh, and now it's completely obliterated. Incredible. Well, if I zoom in, will it be readable? Nope, apparently not. Sorry about that. But yeah, that stuff that I've highlighted in green over here should be the same as this. That's the green stuff. Does that look all right? I mean, I know it's like doing these multiple levels of the chain rule. Let me see if I've got one for you to practice, or rather one that I care for you to practice. I might not. That one's easy. Oh, this one's a good one. Okay, let's do this one, and then we'll go back. So I've got one more slide that I want to make sure I do. Yeah, this one's fun. See if you can do this one completely. And you're going to use the chain rule twice for this. And if you're not sure where to start, let me just make one minor notational change here. This is the same as 5 times the cosine of pi t squared. So if you're not sure where to start, hopefully that'll get you started on this. Freeze this. It's not pi. All right, let me go ahead and do this one and talk through this to explain how I would do this without writing all the F's and the G's. And if you need the F's and the G's, I want to encourage you to do that. Write down the F's, the G's each time, especially when you're on a test. But I just want to show you that it's not entirely necessary every time to write the F's and the G's. So here's the way I think of this in my head. So if you'll indulge me for just a minute, I think of this as being a giant blob to the second power. There it is. So there's my giant blob. So I have 5 times the giant blob raised to the second power. So when I do the derivative of a blob raised to the second power, I get 2 times the blob, right? I mean, that's what the derivative of blob to the second power is. And so here's my blob. And then I'm going to get 2 times that. But don't forget the 5. So 5 times 2 times the blob. So far, so good? I mean, that's what the derivative of something to the second power is. It's 2 times that something. But now I have to be careful and say, wait a minute, that's not a blob. I was just imagining it being a giant blob. And so I get rid of this blob up here and say, oh, that's not a blob. It's cosine of pi times t. And so I go over here and I write down cosine of pi times t instead of the blob. I'll get rid of the blob momentarily. But then, because there is a cosine of pi times t, now I've got this to contend with. And I have to think in terms of another blob. So give me a sec here. Let's make this one brown. So that's the thing that's going to cause me trouble. So let's just put that there. And I think through what's the derivative of cosine? The derivative of cosine is the negative of sine. So I'm just going to copy this down. I'm going to write down negative sine of this blob. There. So I've done the chain rule once. So I think of this as being called the chain rule because I'm going to be continually doing the same thing over and over again as a chain. So I do the derivative of the outermost function, that's the square, 2 times this thing. Then I'm going to do the derivative of cosine, put it there. Now let's deal with what's being hidden by that brown blob there. Let's see, what is being hidden? Oh, it's pi times t. I better put that in here. This is pi times t. I'll clean this up so you can read everything in just a sec. And so I need to do the derivative of pi times t, which is just pi. So let me clean it up, get rid of all the stuff, the blobs. So that is unnecessary, that's unnecessary, and that's going to be my final answer. But in order to do this, I did the chain rule twice. So if you wrote it out, you probably, I don't know which way you did it, but you probably had cosine pi of t as the inner function, and x squared is the outside function. So you have 2 times this thing to the first power. And then you had to deal with the derivative of cosine, which required you to do the chain rule again, and that's where this came in. So like I said, you don't have to, I'm not saying, in fact, I'm encouraging you to write out the f and the g, but I just wanted to show you at least once that, honestly, I don't write the f and the g at this point. I've been doing this for too many years, so I'm too lazy to do that. But it's always a good idea to write out the f and the g. And in fact, even here, I've rearranged things considerably. And it's hard to see where the original derivative came from. So at the very least, write it out carefully using the chain rule however many times you need to. Oh yeah, what do you think, Elena?
So if you were to write it out as the f and g
Mhm.
and had the outermost f as 5, it would be 5x, and then the derivative.
Oh, well, I wouldn't have done that. I would have done this for the outermost function in
Okay.
g. I mean, then you would have 3 chain rules, which is fine. So cosine of pi t. So this is where I would start, and then I'd have f prime is 10x, and g prime is, oh, got to do the chain rule a second time, so then you would do like f is cosine, and g is pi times t, f prime is negative sine, and g prime is pi. So then I'd come back up here, and whoops, sorry, this is in my way. And we'd have negative sine of pi t times pi. So anyway, that's where I would go with this if I were to do this using the chain rule twice, writing it all out. So that's kind of what it would look like. Chain rule is especially, let me just show you this though. before we do the last little activity or exercise, and that is that if you have something like this, let's just do tangent of 3x. If I want to do the derivative of that, there's no way I would ever write out the chain rule with f and g. I'm just saying. And the reason is that the way I would do this is I would say to myself, what is the derivative of tangent? Derivative of tangent is secant squared. And then multiply by the derivative of 3x. Even if you have something like this, y is equal to, how about cosine of x to the third. Even that, I would never write out f and g for this. You might want to the first few times, but after a while you see the pattern that y prime is negative sine. Don't mess with that inner function, but then multiply by 3x squared. So anyway, you'll get more used to doing it, and then you can sort of drop all the extra notation. Okay, one more thing to do, and that's this. We did something like this with the product rule and the quotient rule, so now this is the chain rule version. I want to find f prime, capital F prime of 1. Let me do this one for you. So if f of x, let's just focus on that right now. Let's not worry about that table. If capital F of x is little f times little f of little g, then capital F prime will be, using the chain rule, little f prime evaluated at g times little g prime. That means that capital F prime of 1 will be little f prime evaluated at g of 1 times g prime of 1. So anyway, now that we've got all that sorted out, we can go up to this table and say, okay, g of 1, let me zoom out all the way, g of 1 is 2, so that's g of 1. G prime of 1 is 6, so there's g prime of 1. So let's mark those down. So that will be f prime of 2 times 6. So there's that, and there's this. So far so good. We're just taking the numbers directly from the table instead of taking numbers by computing functions like x squared. Now I need to know what f prime of 2 is, and it looks like f prime of 2 is 5. Isn't that right? F prime of 2. Yeah, I'll just do that. So f prime of 2 is 5. So this should equal 5 times 6, or 30. We have 3 minutes. We could do this, just the next one. The next one is similar. So see if you can work that one out, letter B, using this table. And I'm just going to get rid of my highlighting in the table, since we might want to highlight again. So even if you haven't found all the numbers in the table, you should have figured out that the derivative of capital G is the derivative of little g evaluated at f of x times the derivative of f, So that's just the chain rule. And I know that this is backwards, isn't it? Instead of f of g of x, I have g of f of x, but it doesn't matter. It's the same shape, if you will. You always do the derivative of this thing, and then you leave this thing alone, and then you do the derivative of whatever's in the parentheses. So that's that. So if you didn't get that, then now there's that. Now you can look up the stuff in the table. I'm just going to copy down G prime of 3. G prime of F of 3. All right, so this isn't too bad. G prime of 2 times 7. So hopefully you see where I got my G prime of 2. The 2 came directly highlighted. And then G prime of 2 I can read is also 7. So this one's 7 times 7, which is 49. Beautiful. All right, so hopefully that'll at least get you started on the homework. The homework is similar to all of these. I'm going to stop recording just in case anyone needs to chat. Once I figure out where my mouse is, there it is. It is stopped.